Hi everyone, my name is Maurice Gleeson and I'm going to be talking to you today about which DNA test is best for you. And this is a recording or a re-recording of a presentation that I gave at Who Do You Think You Are Live 2015. The quality of the sound was not the best because there was such a loud hubbub of background noise. So unfortunately you're not going to get the roar of the crowd and the smell of the grease paint in this particular presentation, but you will get a very clear talk on which DNA test is best for you given your own particular family history research circumstances. Now, here's an example of my family tree. There's me at the bottom, my parents, grandparents, great-grandparents, and so on, going up to about 1800, and you can see that I've identified around about 50% of my great-great-great-grandparents, and the other 50% are currently unknown. So these are my own particular brick walls, and that's after exhausting the usual sources of traditional documentary resources such as the family lore, letters in the attic, the family Bible, for Ireland anyway, the 1901 and 1911 censuses. Griffith's valuation in the mid-1800s, and then the cancelled books from the valuation office going up to about the mid-1900s. We also have birth, marriages and deaths, which started for Catholics in 1865, this is civil registration, and non-Catholics in 1845, and we also have church records, which, depending on where you are, can go back to about 1800, even slightly beforehand if you're very lucky. Then there's also collaboration with other researchers through internet websites such as ancestry.com, Genes Reunited, MyHeritage, RootsWeb, and so on. And for those of us who live in Dublin, the Glasnevin Cemetery Records, a very, very useful resource. The newspapers, of course, add a lot of flesh onto the bones of your family tree, and we also have the 1939 electoral roll. But having exhausted all the usual sources of documentary evidence, we are left with a brick wall around about 1800 to 1830, and that is where our research stops. But DNA can help us break through these brick walls, and from my own experience it has helped me in one ancestral line, and it takes me back to Limerick in the 1600s. So it can be a very, very useful way of jumping back several generations with just a little DNA test. Now, various companies provide DNA testing to their customers. We're going to focus largely on family tree DNA today because they have the best infrastructure for helping their customers work together within projects to help identify where the common connection is and to break through brick walls in people's family history research. But there are other companies and they all have their pros and cons. There's a very good comparison chart on the ISOG wiki page which compares the various companies for the various tests that are on offer. What can you get from a DNA test? Well, firstly, a community of avid genetic genealogists, information on deep ancestry and human migration pathways, your ethnic makeup. You can connect with long-lost cousins, you can find out what percent Neanderthal you are, and you can also attain medical risk assessment. Let's look at the first of these, a community of avid genealogists, and this specifically is the International Society of Genetic Genealogy, and the website addresses are there. And a variety of mailing lists are also available, such as the DNA newbie list for those who are completely new to DNA testing, and the ISOG mailing list, both of which you should subscribe to if this is your first time doing a DNA test. To join ISOG is completely free. Everybody should join it because it has a wonderful variety of resources, and there's no subscription. We believe that you should spend your money on doing DNA testing rather than subscribing to a society. The ISOG has a wonderful Facebook group which is very, very supportive, and there's over 6,000 members in that group now. You can pose questions, seek advice, get support, get guidance on your own particular DNA query. The other thing that ISOG have is a wiki page, and this is where you have all the information about DNA that you were afraid to ask for. And this is very, very comprehensive and has a lot of information. I certainly would encourage you to check it out. The community of genetic genealogists are so enthusiastic about encouraging people to test that a lot of the project administrators of the various surname projects, and there are over 8,000 surname projects on family tree DNA, they have occasionally offered to pay for your DNA test. So if you see your name up here, then contact the project administrator involved by going to the free DNA test page on the ISOG wiki and dropping them an email on the email address or contact details that they have supplied there. Taking a DNA test in itself is very, very easy. It's a simple mouth swab, or you spit into a little test tube. That test tube then gets sent off in the post. It gets examined by the lab, and they put it through the machine, and then the results are posted on your own personal web page, for which you have your own username and password. Not only that, but they compare your results with everybody else's results in the database. And a lot of the companies now have a database that is approaching 1 million people. And the more people that test and the more that the database grows, the more matches you will get and the closer those matches will be to you. So the power of these databases to break through our brick walls in our family tree will only increase with time. These list of matches are also posted on your web page, and you can contact them to find out if you can discover where the common ancestor might be. So collaboration is a very, very important part of DNA testing and DNA research. The one thing that Family Tree DNA does more than the other companies is they've actually created an infrastructure which allows anybody who has done a DNA test to start a project on their website. And like I said, there are over 8,000 surname projects, but there's also haplogroup projects, geographic projects, and even heritage projects, which we'll talk a little bit about later on in the presentation. So once your DNA gets to the lab and they take it out, they look at the cheek cells that you've dislodged during the swabbing process, and here's an average cheek cell, and you can see that in the middle is the nucleus of the cell, and just below the nucleus are these little blue things which are the mitochondria. Now each of the mitochondria contain mitochondrial DNA, which is circular in nature, and this mitochondrial DNA is passed up through the mother's line. That's how it descends down the mother's line. So it's very, very useful for tracing your mother's line. Inside the nucleus, there are 46 chromosomes arranged into 23 chromosome pairs. So each chromosome pair has a copy of the chromosome from the father and one copy of the chromosome from your mother. And that applies to all of the 23 pairs of chromosomes. So you've got 2 chromosome 1s, one from your father, one from your mother, 2 chromosome 2s, and so on. Chromosome pair number 23 is also known as the sex chromosomes, and there's 2 types of sex chromosome, an X chromosome and a Y chromosome. And you can see that that particular pair of chromosomes are different sizes, whereas all the other ones are more or less the same size, the same length. So the sex chromosomes, if you get 2 X chromosomes, then that makes you a female. And if you get an X and a Y chromosome, then that makes you a male. We'll be looking at the 3 main types of DNA test, which are the Y DNA, and because Y DNA only gets passed on from father to son, it's a very, very useful way of tracing your father's line. And that has a reach of about 338,000 years, going back to before we came out of Africa. At least that's true for present-day non-Africans. Present-day Africans, of course, have remained within Africa, going back to the dawn of the human beings. The other main type of DNA test is the mitochondrial DNA test. This goes back along your mother's line and has a reach of about 200,000 years, which takes us present-day non-Africans back to Africa about 50,000 years ago, and then into Africa, going back about 200,000 years. All of the other ancestral lines within the middle of your family tree are assessed by using autosomal DNA, which has a reach of about 5 to 7 generations and would take you up to about the level of your great-great-great-great-grandparents, your 4 times great-grandparents, and you have 64 of those, so it helps you connect with distant cousins with whom you share a common ancestor within the last 5 to 7 generations on average, which takes you back to about the level of your 64 4 times great-grandparents. So to recap, Y-DNA and mitochondrial DNA are very, very good for deep and recent ancestry, but they only examine the outer limbs of your family tree, your father's 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 side, your mother's 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 side. All of the 64 ancestral lines going back to your 4 times great-grandparents are assessed with autosomal DNA. So it is in many ways much more comprehensive than the other two. Let's look at the first one then, Y-DNA, and this will give you information about your deep ancestry. It also will allow you to connect with same surname cousins and will allow you to enter surname projects which will help break through brick walls on your father's 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 line. So here's your average Y chromosome. It has a short arm up here at the top, and then there's the centromere, and then there's a long arm, and you can see that along the length of the chromosome are a variety of different genes which code for a variety of different characteristics that men particularly share, such as channel flipping, the inability to see or hear the obvious, catching and throwing, and the ability to remember and tell jokes. Okay, so these genes are rather tongue-in-cheek, but it gives you an idea of how genes are dotted along the length of any of the chromosomes, the Y chromosome being the case in point. The other thing that are dotted along the length of all the chromosomes are DNA markers, and it's these DNA markers that are very, very useful in telling us how related somebody else is to ourselves. And there are 2 types of DNA marker, and here is the Y chromosome again. It's unraveled, giving us a picture of the typical double helix that Watson and Crick found in the 1950s. And here, all along the length of the double helix, we have these nucleotide bases. And they're either guanine, cytosine, adenine, or thymine, labeled GCAT. G always binds with C, A always binds with T. So you'll always find these paired up along the lines, along the length of the double helix, the 2 strands of the double helix. The easy way to remember it is that G and C have curved edges, A and T have straight edges. Now, the 2 types of Y-DNA marker are firstly the short tandem repeat, and repeat is the important word here. You can see that this particular marker, which consists of 9 nucleotide bases, actually is 3 repeats of TAC, TAC, TAC. So this is a short tandem repeat, and this is the one that we primarily use in Y-DNA testing. The Y-DNA 37 test would use this type of STR marker. The other type of marker is called the single nucleotide polymorphism, and this is simply a substitution. So for example, in this particular area here, the majority of the population might be the letter T, but in this particular instance, we have the letter A instead. And this is a polymorphism, a change from the usual, a substitution of the letter A for the letter T. So those are the 2 types of DNA marker. We'll come back to them later on. The markers that we test with the standard Y-DNA test are the STR markers, and here is a summary of the actual markers themselves. It's divided into 3 panels. Each panel has about 12 markers or so, and you can see that here's the marker name at the top, and below the marker name is the marker value, 13, 24, 14, 11, and so on. So it'll appear in your results as just a string of numbers, and in and of itself, it really tells us very, very little. It'll tell you what haplogroup you belong to, and a haplogroup is simply a collection of people who have broadly the same type of genetic signature. So for example, I belong to haplogroup or M269, which just happens to be the most common in Western Europe. And it tells me that it is much more likely that my ancestors came from Western Europe than, say, from China or from South America. where this particular haplogroup is very, very rare indeed. So it'll give you some indication of where your ancestors probably came from within the last 500 to 1,000 years. Before that, it gets a lot more iffy, and some of the other presentations at Who Do You Think You Are will address this particularly, and I'm thinking of Professor Mark Thomas's talk in particular. So that is all that the values will tell you in and of themselves. That the real value in these marker values is when you compare them to everybody else's in the database. They will tell you roughly how your haplogroup migrated from Africa. If it migrated out of Africa, as the haplogroup OR group did, it'll show you crudely the path that your ancestors took tens of thousands of years ago to arrive into Western Europe. But it won't give you the fine detail of that migration. It will also tell you roughly what group you fall into and what percentage of that group occurs in various places. So you can see that in Europe, haplogroup OR accounts for 45% of the European population, and in fact once you get into Great Britain and Ireland, those percentages go up. So it's about 70% in England, 80% in Scotland and Wales, and up to 90% in parts of Ireland. The real value, like I say, with these Y-DNA STR results is when you compare them to other people. And one of the first things you should do is see if there's a surname project for your particular surname. And you just go to the Family Tree DNA homepage, enter your name in the search box and click on enter and see if your surname is in the database. The alternative way to do it is simply Google FTDNA and your surname and see if anything comes up. And this is the sort of response you get when you do this search. I search for Gleeson with 2 E's, and I can see that based on this search, there are 22 Gleesons in the database at Family Tree DNA. Not only that, in terms of surname projects, there is a Gleeson surname project, 2 different variant spellings of the word Gleeson, and that has 89 members. Now, there's only 22 with the spelling Gleeson, so I'm assuming that the 89 members will largely have the spelling with the E and the A. And if I do a search for the E and the A variant, then it comes up with 74. So the majority of Gleesons in the database will have the EA variant spelling. To join the Gleeson project, I just simply click on one of these links here. The worldfamilies.net is the website that is hosting the particular project. And once I go to the project, I can see that people have supplied their patriarchs. And here is a Leeson patriarch that goes back to 1610 in Cockfield in Suffolk, England. So these are the English Gleesons. These are the Irish Gleesons, and you can see that most of the Irish Gleesons, they stop around 1780, 1790, so the late 1700s, early 1800s. And my particular Gleeson is down here at the end. I'm brick-walled at 1832. And this is typical of all Irish Gleesons. We stop around about the 1800 mark. The results page is quite interesting, and you don't need to see the detail here. You just need to see the pattern. So this is lineage 1, and these are the English Gleesons, and here's lineage 2, which is one group of the Irish Gleesons, and you can see the patterns that are emerging. This lineage 1 has an orange line down here, a purple and blue one here, another orange one here, beginnings of a blue one here, and an orange one here. And this particular pattern is very different from the pattern that you see for lineage 2 Gleesons, indicating that these two groups are not genetically that similar, and therefore they do not share a common ancestor probably for several thousand years. But with anyone within the group who has the same pattern of genetic signature, they would be related to each other probably sometime within the last couple of hundred years, 200, 300, 400, 500, that type of thing. Lineage 3 has a completely different pattern altogether compared to the other two, and there is an ungrouped group as well, and you can see that the pattern here is rather haphazard for this group, and it doesn't match any of the existing patterns in lineage 1, 2 or 3. And that really illustrates the value of your YSTR results. Your string of values is compared against everybody else's string of values, and these patterns of matching emerge that allow you to be grouped in a particular genetic family. I also explored one of my Spearin ancestors, but of course my direct male line goes back to Leeson. I'm Gleeson, 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 Gleeson. So in order to get Spearin Y DNA, I had to go back up my family tree to my great-great-great-grandfather and then trace all of his ancestors down to the present day and find a direct male line ancestor that is related to my great-great-great-grandfather by his father's 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 line, and that was my third cousin, who still carries the surname Spearin. He agreed to do the DNA test, and that's how I got Spearin Y DNA for my particular family tree. And of course, I can do that with any of my male ancestors by finding a direct male line descendant of any of those. Y-DNA testing is also very useful for deep ancestry, and we've seen previously how OR1b is the most common haplogroup within Europe. It accounts for about 80% of people in the UK and Ireland. The second most common one is I1, which has both Nordic and Germanic origins. And of course, for present-day Africans, the majority would belong to the A2, the A3, and the very, very large E1B1A group, which is associated with the Bantu migrations. So Y-DNA testing, very good for deep ancestry. But this is also where SNP testing comes in, and this is the second type of Y-DNA marker, and it allows us to elucidate the finer branches of the Y-DNA evolutionary tree. And it's reaching the stage now, as more and more of these SNP markers are being discovered, that we are becoming much more granular in our ability to identify where a particular marker arose. So for example, with the marker Z253, we see that it's largely concentrated in southwest Ireland. Not only that, but we find that people who have this marker have a variety of different surnames, and certain surnames are popping out as being much more common in this particular group and much more associated with this particular group. And ultimately, as more people test and we get more people providing their most distant ancestral surnames, it will be possible to characterize a particular marker with a particular surname set. And this ultimately will hopefully allow us to link a lot of people with the ancient annals of Ireland. And the same will be true for the ancient annals of Scotland and for any other country where there are ancient genealogies. And this will allow us to go back to the origin of surnames itself and to the point when they became commonly used, which would be around about 1300 or so for most countries, certainly within the UK and Ireland. The other thing that one should do with a Y-DNA test is to join haplogroup and geographic projects. Now, haplogroup projects use SNP testing, such as the Big Y test from Family Tree DNA, to define the smaller branches of the human evolutionary tree. Subgroups may eventually be associated with specific clans, tribes, and ethnic groups, as I've just said, and certainly for people in the UK and Ireland, OR1b and subclades would be a very, very popular haplogroup project because it signposts you to smaller, more specific projects such as the OR-L21 project, the M222 project, which is specifically Nile of the Nine Hostages, Z255, which is my own particular one, and the L226, which is associated with Brian, Baru, and the Dalcassian families. Geographical projects in Ireland include the Ireland Y-DNA project, the Munster Irish, the Ulster Heritage. In England and Britain, we have the Cornwall, Devon, Northumberland, Essex, Wessex projects, the Anglo-Saxon, the Bristol Channel, and the Isle of Man projects. And a variety of heritage projects are emerging in recent years. And these look at a particular group of people to see what exactly happened to them and to try to elucidate what happened to a particular group. And a very, very good example, and very interesting example, is John Cleary's Scottish Prisoners Project. And this is really in the early stages, but it will have immense historical importance as well as family history importance. And basically this looks at a group of Scottish prisoners who were rounded up by Oliver Cromwell after the battles of Dunbar and Worcester in the 1650s, force-marched to Durham Cathedral, where several thousand of them died, and then the remainder were shipped over to the West Indies. And their descendants are still alive today around the New England area, possibly other areas as well. And John's project looks to try and find the descendants of these Scottish prisoners and help to elucidate what happened to them after they were transported over to America, and ultimately, of course, reuniting them with their cousins in Scotland who are still alive today. So a fascinating project, and you can find out more about it by clicking on the web link there at the bottom of the screen. So is a Y-DNA test the best test for you? Well, it'll tell you about your deep ancestry, the human migration path that you took out of Africa, and your haplogroup. It may eventually link up to the ancient annals, but that'll probably require some additional SNP testing alongside the standard Y-DNA 37 test. It's useful for confirming a relationship between two men on their direct male lines, and there are over 8,000 surname projects run by volunteers on Family Tree DNA who has been kind enough to supply the infrastructure for the genetic genealogy community to do so. And these surname projects can certainly help you break through brick walls on your father's 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 line. Geographic projects help elucidate the relationship of your particular surname to other surnames in the same general geographic area and can be very informative too. And haplogroup projects will tell you what SNP to test in order to help elucidate what finer branches of the human evolutionary tree you belong to, and that in turn will help you decipher which migration routes your particular set of ancestors took. Heritage projects can tell us what happened to a particular group, and the Scottish Prisoners is a very exciting example of that. And project administrators themselves are a great source for advice and support, so please don't hesitate to contact them when you have joined their particular project and ask them for further advice. So that's the first type of DNA test. The second type of DNA test is the mitochondrial DNA, and this is very useful for deep ancestry and to an extent for recent ancestry, but really it is the least useful from a genealogical point of view of all three of the DNA tests we'll be talking about today. And this has a reach of about 200,000 years and will help you find your connections to common cousins with whom you share a common ancestor on the mother's 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 line. Here is an example of the map that we have for deep ancestry, and it shows you the various routes that different peoples took out of Africa as they spread across the globe over the space of several thousand years, and you can see the expansion times that human beings emerged from Africa and moved across the globe, finally populating the peripheries of the world around about 8,000 to 10,000 years ago. To illustrate the usefulness of mitochondrial DNA from a genealogical perspective, I'd like to tell you a little bit about the king in the car park, Richard III, the Hunchback King. And Dr. Turi King gave a fascinating presentation on this at the Who Do You Think You Are Live 2015. Unfortunately, for copyright reasons, it will not be up on the website, on the YouTube channel. But if you do get a chance to listen to Dr. King at any point in time, it's well worth making the effort to go and hear her. She really gives a fabulous lecture. Now, Richard III was buried after the Battle of Bosworth in 1485, and here is a memorial plaque in Leicester Cathedral to his demise, but his body isn't there, or at least it wasn't. He has been buried there since. The story went that he was killed at the battle and then buried in the Church of the Grey Friars. Philippa Langley, who was the head of the Richard III Society, her society felt that Richard III was a much maligned prince, and that the bad representation that we see of him in Shakespeare's play of the same name was largely propaganda by the Tudors. He was actually a very good king, and he wasn't a psychotic murderer or a hunchback with a withered arm and a club foot. These were all techniques and devices used to try and discredit him. So Philippa Langley and the Richard III Society for many years have been on a campaign to try and resurrect and restore his proper standing within society. And they've done a lot of research, particularly into the Greyfriars Abbey, where he was thought to have been buried. And they superimposed an old map of Greyfriars onto a modern map and found that people for centuries had been looking in the wrong place, and that Greyfriars Church, the site of the Greyfriars Church, would have been somewhere around about the car park of Leicester Social Services. So they went along to Leicester Social Services and after raising some money and said, "We have £10,000, can we dig up your car park please?" Leicester Social Services said, "Yes, of course, would you like sandwiches with that?" And they, on the first day of the dig, they actually came across some bones. And the heavens opened, and there was a torrential thunderstorm, and the rain came down as if the body of Richard III had been let loose from the grave, hot from hell, crying havoc where it went. Quite Shakespearean and a wonderful dramatic event. But they didn't think that the bones were those of Richard III because it appeared that there was a skull at a much higher level than the rest of the body. And for that reason they thought they'd found two bodies instead. But a little bit more digging helped them realize that in actual fact the reason why the skull was so high was because the body had a curve in the spine and had been buried rather hastily, which meant that it was a little bit squished. Interestingly, the Victorians had done a lot of building on this site, and they came within 1 centimetre of seriously damaging the skeleton. So it's a little bit of a miracle that we actually found the remains of Richard III at all. Further tests were done, further digging. The archaeological dig revealed that the architecture of the Greyfriars Church and the place where the body was found was in fact in a place that you'd expect royalty to be buried. The skeleton had a variety of battle wounds, including a hole at the top of the skull and various slices off the skull, which would have been possibly due to sword injuries. Then there was a humiliation wound on the pelvis, and this is the pelvis of the skeleton, which shows a mark on the one of the bones there, and analysis of the contents of the skeleton indicated it was a rich diet that would have been only or more likely to have been consumed by royalty. And they found a direct descendant of Richard III, or rather a direct relative of Richard III, and this was Michael Ibsen, and here you see him swabbing his cheek, looked upon by Dr. Couturi King herself. And they've also done facial reconstruction using the skull, and this produced this particular model, which was quite similar in many ways to what we see in portraits. So the totality of the evidence, because the chap Michael Ibsen did also match the DNA recovered from the bones that were found, the totality of the evidence suggests that this is Richard III. But this particular slide here is very, very useful for illustrating the direct female line of descent. Now, Richard being a male, of course, he would not have passed on mitochondrial DNA. It would have been any wife that he married. She would have passed on mitochondrial DNA to their children. So we can't use the descendant's DNA in this particular situation. We have to go back up to his mother, which is Cecily Neville of York. And she passed her mitochondrial DNA onto her daughter, who would have been Richard's sister, Anne of York. So we can see what mitochondrial DNA Richard probably had by following the female line all the way down to the present day. And Anne had a daughter called Anne, who had a daughter called Catherine, who had a daughter called Barbara, Margaret, Barbara, 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 Anne, thank goodness, Charlotte, Charlotte, Muriel, Joy, and finally Michael Ibsen. He would have been the last in the line because, of course, he would not have been able to pass on the mitochondrial DNA himself, being a man, but one of his sisters would have been able to pass on that mitochondrial DNA. And his mitochondrial DNA was a match for the mitochondrial DNA found in the bones that they recovered, indicating that there was a high likelihood that this was indeed Richard III. Now, they also traced another direct female line descendant of Richard III, and she was just one single mutation off from an exact match to both Richard III and Michael Ibsen, and the totality of the evidence, like I say, suggested that this, beyond reasonable doubt, were the remains of Richard III. So is a mitochondrial DNA test the best test for you? Well, it'll tell you about your deep ancestry, what haplogroup you belong to. It's useful for confirming a relationship between two people on their direct female lines, as we did with Richard III. And once again, the project administrators are a great source for advice and support. Please don't hesitate to contact them. The third type of DNA test is the autosomal. Now, remember, your direct male line and your direct female lines are just one ancestral line out of many. Your paternal side has 32 ancestral lines, going back to the level of your 4 times great-grandparents. Your maternal side has 32 ancestral lines, going back to the level of your 4 times great-grandparents. And an example of how misleading a Y-DNA test or a mitochondrial DNA test can be in giving you the overall picture is illustrated quite nicely by this gentleman here, Professor Henry Louis Gates, the mastermind behind Finding Your Roots, and he also has a very, very entertaining and educational website called The Root. You can see the web links there. But his wonderful television series, Finding Your Roots, incorporates traditional genealogy and genetic genealogy and is the best television series around at the moment. You can find it on YouTube if you're living in the UK and Ireland, and it is a wonderful resource. But Professor Henry Louis Gates did his own DNA testing, and he found that when he did his Y-DNA, it came out as OR M222. Now, OR1b, as we know, is the most common haplogroup within Western Europe, and this particular genetic SNP marker, M222, is associated with Niall of the Nine Hostages, that ancient, possibly mythical warlord that emerged from Northern Ireland about 500 to 900 AD, sometime around that point. So his father's 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 line goes back to a European man. He said, okay, well, let me test my mother. He did so, and his mother's line goes back to a European woman. So his mother's 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 line goes back to a European woman. And about 10% of African Americans will have mitochondrial DNA that goes back to a European woman. About 35% of present-day African Americans will have a father's 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 line that goes back to a European man. And this is a vestige of slavery. A lot of there was sexual exploitation of African women, as a result of which a lot of present-day African Americans will actually have a father's 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 line that goes back to a European man. 65% of them will have a father's 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 line that goes back to an African man, and similarly on the other side, 90% of them will have a mother's 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 line that goes back to a European, an African woman, and 10% to a European woman. And this might be because indentured servants or some intermixing of the races since slavery has occurred. But obviously Professor Henry Louis Gates is primarily African American, and it just goes to show that if you just test the one line on the periphery of your family tree and then another line on the periphery of your family tree, you're missing out all of the ancestral lines in the middle. And those are the lines that autosomal DNA covers. So it's very, very important to do autosomal DNA in order to get an overview of your ethnic admixture. And that's one of the first things that autosomal DNA can give you. It can also put you in touch with genetic cousins with whom you share a common ancestor, going back about 5 to 7 generations, 200 to 250 years, around about 1700, 1750 would be the date of birth for the common ancestor. And it also can give you a medical risk assessment if you test with certain companies, 23andMe being the obvious one. And with certain companies, they also give you what percentage Neanderthal you are. For me, I just look in the mirror and I can get an instant notification. Whether you test with 23andMe, Family Tree DNA, or Ancestry DNA, you should upload your DNA results for free to GEDmatch, because a lot of people have done this from all 3 companies, and it means that you can fish in 3 pools rather than just the one. Now, not everybody from every company has uploaded their results, maybe about 10 to 15%, I would estimate, but it does mean that you can fish in 3 pools rather than one, and it provides a lot of useful tools for analyzing your DNA over and above the tools that are provided by the individual companies. And it provides some tools that are only available through GEDmatch, and for that reason, you should upload your results. Here's an example of ethnic makeup, and you can see in this particular instance that this person has 69% European ancestry, 26% African ancestry, and then a smattering of Middle Eastern and Central South Asian. And this can be broken down even further into a sub-regional level, 37% Western and Central Europe, 22% Scandinavian, and only 10% British Isles. So it can be very, very useful for getting down onto a sub-regional level. In due course, and this is within the next 5 to 10 years, we'll be able to break down our autosomal DNA into even smaller sub-regional levels. So for example, projects like the People of the British Isles project and the Irish DNA Atlas project will be able to define even smaller sub-regional levels than the ones we currently have. So for example, in Britain itself, there are currently 17 distinct genetic clusters that we can identify. And Garrett Hellenthal gave a fascinating presentation on that at the conference, and his talk will hopefully be available later on the YouTube channel. One of the main things we use autosomal DNA for is to find long-lost cousins. So for me, and there's me down at the bottom, born around about 1960, I've done my DNA test. It gives me a reach of about 5 to 7 generations, bringing me back to about my 64 4-times great-grandparents, but I've also tested my father, and that allows me to extend the reach in my particular family tree by an extra generation, and I've tested my mother's sister, so that allows me an extra generational reach on my maternal side of the family. Now, to illustrate how useful autosomal DNA can be for confirming suspected relationships within the family, I'd like to tell you a little bit about the mystery of the wedding memento, and specifically my long-lost relative, Ruby Kathleen Leeson. Now, several years ago, as my dad was going through his grandfather's papers, this fell out, and it turned out to be a wedding memento of David Patterson to Ruby Kathleen Gleeson. They were married at Thargomindah, the 23rd of March, 1893. Well, Dad said, I know nothing about this person. Can you do some research and see just exactly what this is all about? So the first thing I did was I did a Google search for Thargomindah, and you can imagine my surprise when I found it was in the middle of the Australian desert, surrounded by poisonous snakes, man-eating koalas, and teetering on the brink of nothing. So the first question was, well, what the heck was Ruby Kathleen getting married to somebody in the middle of the desert? And secondly, how did her wedding memento end up halfway around the world in Dublin in my great-grandfather's papers? So the hunt was on. Now, we knew from the wedding memento that she was married in 1893, so I sent off to Australia for her marriage record. And this was very interesting because it stated that her parents were John and Anne Gleeson. And I thought, fantastic, because my great-great-grandparents were John and Anne Gleeson. Could they be one and the same couple? How many John and Anne Gleesons could there be? Well, actually, my Anne Gleeson had a brother called John Gleeson, and she had a sister called Catherine Gleeson, who married a John Gleeson. So there are 3 John Gleesons in the same family. This was no guarantee that these two couples were one and the same. And the marriage record stated she was born in Longstone. I said, fantastic, because my great-grandfather was born in Longstone, and his siblings were born in the surrounding townlands. So this placed them in the same geographic area. It also stated that her father was a hotel keeper, and then on the death certificate it said that he was a farmer. Well, my John Leeson was a labourer. He was never in a hotel in his life, I'm quite sure. And we think that probably she was trying to beef up her CV and maybe told a little porky pie about her father's profession in order to clinch the marriage with David Patterson, who was a hotel keeper himself. The date of birth was given as variously 1872 or 1869, depending on the marriage record or death record for Ruby Kathleen, and this tied in with the birth records that we had for the siblings of my great-grandfather, Catherine in 1868, Bridget in 1872, Winifred in 1877. We wondered whether Catherine in 1868 could have maybe changed her name to Kathleen when she moved to Australia. A tantalising possibility. We knew also that Ruby Kathleen had arrived in Australia around about 1886, based on her marriage and death records. And this tied in with the death of my great-great-grandfather, John Leeson, in 1885. We also had family lore that Timothy and Winifred went off to Australia at some stage, and that Winifred had a daughter who was a concert pianist or a concert singer, something like that. And that was all we had. So I put the draft family tree I had for Ruby Kathleen up on the internet, on a variety of internet sites, and on Genes Reunited 2 years later, and it did take 2 years of patient waiting, I finally got a match. And I found somebody who had Ruby Kathleen in their tree. So I wrote to them and said, do you have how you're related to Ruby Kathleen, and do you know any of her descendants? And she said, I do. And she put me in touch with Ruby Kathleen's grandson, Alan, who was in his 80s. And I struck up an email relationship with Alan, and he was able to tell me that she had an uncle and aunt who lived in Sydney. She had a brother who went off to the US and became a baseball player, and he sent them a watch with an inscription on the back, but they've lost the watch since. A lot of very interesting information. One particular piece of information was that Ruby Kathleen had a daughter called Alma, who was a very accomplished musician and excelled at the violin. So a very interesting parallel between the two family lores, ours being that she had a daughter who had a concert pianist or a concert singer. But nothing that we were able to get from our putative Australian cousins was able to clinch the fact that we were actually related to each other. So what I asked Alan to do was would he be prepared to do a DNA test? And he said yes, because if Martin and Ruby Kathleen were siblings, as the evidence seemed to suggest, then my dad and Alan would be second cousins, and they should share about 3% of their DNA in common, within a range of about 1.3 to 4.3%. So Alan agreed to do the test. The results came back, and they were 2.6%, well within the range that you'd expect for second cousins, and therefore the DNA evidence supported the documentary evidence. It basically said that Dad and Alan were definitely related by sharing 2.6% of their DNA in common. Me and Alan, in fact, shared 1.5%, almost exactly the population average. And as a result of that, we were able to say that Dad and Alan definitely genetically related. The best fit was second cousins. It has confirmed a suspected relationship with 99% probability. Many unanswered questions remain, but DNA helps focus further research. Which of the sisters became Ruby Kathleen? Was it our Catherine, or was there another sister? So Ruby Kathleen has been saved from the shoebox of obscurity. She is no longer going to be put into that shoebox and shoved under the bed forever. We actually have resurrected her and established that we have new cousins in Australia and vice versa. So autosomal DNA can be very helpful for answering specific questions. It can confirm that two people are related. It can help focus further research and is a very useful extra tool in your genealogical toolkit. However, most people who do autosomal DNA testing do it as a kind of a fishing trip. They throw their hook into the gene pool and see what they can catch. And you can test with any of these three companies. With Family Tree DNA, this is my results page. You can see that my name is up there and my kit number. And I've hidden the first names to privatize these individuals, but you can see a Hare, a Haddon, a Spearin, a Swords, a Maguire. Then it also provides the relationship range. So this person here is a second to fourth cousin. We haven't figured out how he fits into the family tree at this point in time. This person down here is also a second to fourth cousin, and again, we don't know how they fit in. This column here tells you how much of your DNA is shared in common, and here you see 104, 61, 66, 45, and 56 centimorgans, represented by a small c and a big M, and centimorgan is just the unit of measurement for DNA shared. Just to give you an example of what a father and a son would share, it would be around about 3,300. So 104 is a lot less and indicates a second cousin once removed in this particular case. The secrets to success with autosomal DNA are to have an online tree with the names and the locations of all of your most distant known ancestors, and you collaborate either one-to-one or in small groups of people who share the same DNA segment. And Family Tree DNA have a little email icon beside each of the matches that allows you to contact them by email. Remember that DNA is a pointer. It tells you where to look, and it gives you a clue for further research, further documentary research. So it doesn't mean that you don't do any documentary research, it just tells you where you need to search next. Is autosomal DNA test the best test for you? Well, it'll give you your ethnic makeup, what percentage Neanderthal you have, and your medical risk if you test with certain companies. It's useful for confirming a suspected relationship between two people on any ancestral line. It works best with close matches, up to third cousins. Most matches will be from the US because that's where most of the people who have tested so far come from. For Irish DNA, Irish Irish genealogy research, the 1800 brick wall remains a problem, and getting beyond that can be quite complicated, and it is very easy to get bogged down. That's why it's so important to join the various ISOG Facebook groups, the mailing lists, and also to contact your project administrator for ongoing support and guidance. DNA testing is not without its limitation. It's not a substitute for documentary research, just an extra tool. The cost has come down considerably in recent years. So you can get a Y-DNA test for as cheap as $59, a mitochondrial DNA test for $69, and an autosomal DNA test for $99. A lot of people complain about difficulty understanding the results, and a lot of people find them that they are too technical. So again, the support that the ISOG group offers in terms of its Facebook page and mailing lists and the ISOG wiki is invaluable. Privacy and data protection will always be concerns for a lot of people, and there are certain legal implications. So for example, if you were a multimillionaire, I would not advise you to get your DNA tested, because you never know who will climb out of the woodwork. NPEs, non-paternity events, not the parent expected, will pop out from time to time. And you may find that you are secretly adopted, you may find that you have half-siblings that you know nothing about, and you might find that you were switched at birth, as happened with a Canadian chap recently. So these are all surprises that you have to be aware of. They may happen to you, but they are the exception rather than the rule. If you don't want to know, don't get tested. Very, very strong advice. Your matches, where do they come from? Like I said, mainly from the US, but about 30% of the Family Tree DNA database is non-US, and I get most of my close matches there being Irish. 23andMe have about 90% of their database from the US, about 10% non-US, and Ancestry DNA have just launched over here in Britain and Ireland, so about 99% of their database is non-US. But this is going to change over time as more and more people from Britain and Ireland do test. Which company to test with? They all have their pros and cons. So do a little bit of research. Check out the comparison guide on the ISOG wiki to see which one is best for you. Also, the different company databases don't talk to each other. So if you're in one database, you can't compare yourself to people in the other databases. There are various public databases where you can upload your results free of charge, and that allows you to fish in 3 pools at the same time. YSearch, Mitosearch, and of course GEDmatch are very, very useful, but they are not used enough. Only a relatively small percentage of people, 10, 15, 20%, upload the results to these public databases. And you should upload yours to all of these databases to encourage other people to do so. The most popular tests that people have done in Britain and Ireland, you can see in Ireland back in 2013 we had 113 tests, 99 kits. 50% of them were Family Finder, which is the Autosomal DNA test. 40% of them were Y-DNA37, which is the father's line, and about 10% of them were mitochondrial DNA tests, that's the mother's line. Then in 2014, at Who Do You Think You Are in London, we sold 485 kits for 550 tests. The most common again was the Family Finder Autosomal DNA test, with 41% of people buying that. Y-DNA tests were purchased by about 30% of people, and mitochondrial DNA tests were again bought by about 29-30% of people. So you can see that the most popular test is the Family Finder, followed by the Y-DNA37, followed by the mitochondrial tests. So that hopefully gives you an overview of what DNA testing is all about. And I hope that you have success in your DNA testing, and wish you the very, very best in your future genealogical endeavours. Thanks very much.